This is the description of the solution for the 1993 James Roos High School trial paper, question 9. As usual, the question's over here, and if you haven't already done it, you should stop and attempt this question as best you can now, and then come back for the solution. Okay, so in the meantime, the solution is this. So here's the information. The first thing we have to do is draw a diagram. Now I've got the diagram printed here twice, but down the bottom here I'll leave it on the screen. And just make sure you interpret the question carefully and correctly. So there it is there. Show that the total length of the roads PA, so this diagonal, PB, this diagonal, and PC, this straight line, is given by that. Well, by drawing this diagram, we see we're working with triangles, and in fact the hypotenuse of the triangle, so on the right hand side here, we're given this information. Now this just to begin with, this line here, just keep putting information in for an examiner. Given that PC is x, which is what we're told, then dp equals 10 minus x. So we found the length of AP. Now the question refers to PA. Now it doesn't matter. I would have written PA had I been alert to that, but I just missed it, so it doesn't matter. So there's Pythagoras, and I've described where it comes from. Notice that the square root of both sides is a positive and negative result, and I've described that I'm only using positive distance here. Now we then look at this and say, well, the two triangles, these triangles down here, the left and right, are congruent. Now because this is not part of this, we're not asked to prove congruence, I can use the fact that they're congruent and explain why without providing the whole proof of congruence. Two equal sides and an equal included angle, and so therefore the AP and BP are equal because they're corresponding sides. And so I've got this statement here, and that's adequate given I've shown that these two are equal. I've already said up here that PC is equal to x, so I'm pulling it all together. Part 2 is over here. Show the minimum total length of the three roads is that. Okay, now the word minimum means we're working with a derivative of L with respect to x, and we've been given that in the previous question. It's a show that question. Okay, so the derivative of x is 1, and then I've got to find the derivative of this thing here. Now, I just put it like this so I could walk you through the steps. Always turn a square root into an indice. So the derivative of this thing here is a half. Bring the half down, so bring the half down. Now that cancels with the 2, so that's why there's no 2 here. That to the power of subtract 1 from a half is negative a half, and multiply by the derivative inside the bracket. And that gives me that, and I can write it like that, or I could leave it like that. Now there's your first mark, and you should be able to get that first mark, although students will probably in some cases forget the x as the derivative just being 1. However, that's a reasonably straightforward derivative. And then I've said to find the minimum turning point, dl dx equals 0. Now what happened here was, okay, I was just running out of space down the page. Do not start your solution, get the next part of this solution here. Okay, you've only got 2 lines left, so I've just moved up to the top of the next page. Okay, so this is equal to 0. I've left it as a fraction. Now, I subtracted this from both sides to make it negative. Sorry, I've got 1, brought it over to the right-hand side, and that is negative 1. Then I've multiplied both sides by the square root, so that's why I've got negative square root, and that's the numerator. Okay, so that stayed on the left-hand side, and the negative 1 came here, multiplied to get negative. Now, I can't do anything with this, but I know I have to solve for x. So I'm going to square both sides. That gets rid of both the negative and also the square root sign. So the square of this, now don't forget you are squaring the whole right-hand side. So this is a binomial. You have to expand it and square it. And I get this statement here, which simplifies to that, which cancels to that. There's no factors of 88 that add to give 20, so I'm going to use the quadratic equation, and that's what I get. Okay, so racing through that a little bit. 10 plus 2 root 3. Now don't forget, 2 goes in the 20 and 2 goes in the 4, so I can cancel. Both of these things are positive, so I have to test both of these values. And this is just a real pain because normally you've got a fair bit of substitution just to show what's going on here. Now, what I've done is I've approximated 10 plus 2 root 3 and 10 minus 2 root 3, because that just means I can substitute integers into the original derivative equation. I don't want to go substituting something with a square root in it, not into something as complex as our derivative equation. So 13 and 14 are a whole lot easier. What I find is that I got 2 positive answers. This is not a turning point. Then I substitute from 6.5, 6 and 7, and I get a change in derivative sign. And so this is a minimum turning point. Now for a question like this, do I have to prove this is global? Well, I haven't, and it comes down to, I'm not sketching this thing. The only way to show global, well, it would be reasonably difficult, although you could argue that, just going back to the left-hand side here, this has to be positive, always, and this is positive, so we've always got a curve that is heading upwards where x is greater than 0, and x has to be greater than 0 because it's length, so that would prove our global minimum. Okay, so there's our minimum. Now, PC is x, going back to this diagram, there's x, so that's just 10 minus 2 root 3, and PA was this part of, well, this square root. So by substitution, and I did some working out on the side of the page, I end up with 4 root 3. Okay, and PA and PB are the same, so I've got 10 minus, there's the x value, there's 4 root 3, there's 4 root 3, and my solution is this. Okay, so the tricky parts, I'm just going to now reduce this and have a look at the whole page. The tricky parts of this, well, now there's Pythagoras, that's okay, part 1. Part 2, just be careful with the derivative, because there's plenty that can go wrong in this derivative, although it's not especially difficult. Part 3, the trick here is getting this one to the opposite side and cross-multiplying, because I'm trying to solve this whole thing equals 0. And then I've got to square both sides and square them carefully to get the proper expansion of the left-hand side, the proper expression for the right-hand side. I solve and get this messy combination here, and I have to test them. So there's a lot of work in this to get to the answer. So it's a reasonably difficult question, but there are marks, even if you can't solve it to its entirety, there's plenty of marks here to access on the way through. Okay, so a good question from the 1993 James Roos trial paper.